Hi, very warm welcome. As you can see, I've got a little experiment here set up for you so you can get an idea as to how these little hydrogen fuel cells work. Basically, if you put hydrogen gas on one side of the hydrogen fuel cell and oxygen on the other, you'll be able to generate electricity, which is running this little windmill here for you. I've got a little gearbox on a motor attached to the top, and I've got a little valve over here on the hydrogen gas so I can control it, and it might stop in a few seconds, and then all I do is press the valve, allows a little bit more hydrogen gas to flow over the side of the hydrogen cell, and obviously there's an exchange of electrons which allows us to tap off that electricity. Now I want to show you on the multimeter how much the cell is producing, so I'll just connect that up while we talk, and you should be able to see a voltage, small voltage measurement on the display. As we get in there, let's see. It's always difficult when you're trying to do these things. There we go. We should have on there a small amount of electricity being generated, just under 1 volt, but it's nevertheless enough to run that that motor and turn that wheel or the blades around. So we've got a small amount of hydrogen gas here. I'm still bewildered as to why there is so little oxygen production being performed. I even changed the electrodes in there from the ones that it was supplied with, because the one just totally dissolved, the oxygen one did. So I thought it might have been silicon coated up the electrode on the oxygen side, and still to this point in time I don't know why. I've replaced it with some galvanized screws, and we're getting very, very tiny bubbles of oxygen, but nowhere near the amount we should be getting, because we should be getting half the volume of the hydrogen in oxygen, and we simply are not. So it's a bizarre, why we're not getting that. But what I wanted to do is to show you the principle of these hydrogen cells and how they work and how they produce electricity, because there are some cars already on our roads that use bigger versions of these hydrogen generators, and they run electric motors. But the problem is with hydrogen gas, it is probably cheaper than ordinary fuel, but it's harder to obtain. That's the problem. That's why we're not all using hydrogen cars at the moment. The other thing is it has to be contained in a vessel which can withstand the pressure of liquid hydrogen. And we have got them, but it's not the desirablest way of, in my view, of making them really popular. The other thing is there's a limited amount of hydrogen fuel stations that you can go to in a lot of countries where you can readily top up. They're not, let's say, abundant as charging points for Teslas and other electric cars. Is there a future for hydrogen cells? I definitely think so, especially if we can do away with hydrogen gas needed on that one side, and that's what we've been looking at in some of the experiments that we've been conducting. We're anticipating, and we'll be doing that experiment within the next week, of using ion wind. Now, the preliminary tests we've done using ion wind, what we basically did is we connected up the multimeter to a area of tin foil and put that over the ion wind that was blowing on it, and we got a reading of electricity. And we're hoping that by pumping ion air onto the hydrogen side of this hydrogen fuel cell, it will be able to generate electricity. Why will that be a benefit? Because it's much easier to generate it's much easier to generate ion wind than it is to compress and store hydrogen gas. And if we can get that running, we've just made this much more efficient. Now, earlier models of these hydrogen fuel cells required you to actually pump oxygen over the other side of the plate. So you'd need hydrogen on one side, oxygen on the other. These new ones are running off the 20% oxygen that is in our atmosphere because it's at sea surface level. Hydrogen gas isn't as abundant as oxygen in our atmosphere, and most of the hydrogen gas is high up in the upper atmosphere because it's a lightweight gas and it rises. But you know, let's see if we can use ion wind on the hydrogen side. Now, there is a byproduct of this, and that is water. So you'll get water condense on the one side, and I know you won't be able to see it, but it will, after running for a small amount of time, produce water as its byproduct. So we start off with electrolysis, connecting it to some electric source, only a very, very small amount. I mean, it's not even registering in volts on there, believe it or not. It's just registering a small amount of milliamps, so 0.107 milliamps, very little. And that's enough to generate hydrogen gas and keep this motor running. In fact, we don't need to generate, we can switch the power supply off because we've got enough hydrogen in there probably to run this now for a good couple of hours. And if it should stop, all I have to do is press the valve that will allow the gas to flow over the plate again, and it will continue to generate its electricity. The reason why I've got the check valve on there and I can control it is because I've seen a lot of these experiments on YouTube where they don't show you a prolonged rotating anything using the power off the cell, and that's because they haven't got a check valve on there. What they're doing is they're flooding the cell wall with the hydrogen, and once it's gone, it's gone. Whereas I'm controlling the amount of hydrogen here by the valve, and I'm allowed to allow a little bit in as the time. As you can see, with just the bit that we've allowed to flow through, it hasn't really changed much on the amount of energy that it's producing. So they are quite efficient, and that will be even more efficient if we can get it to run on ion wind. I can generate ion wind with a 9-volt battery, and I can generate a constant stream of that. And it's just a matter of, you know, instead of having the check valve on there, I could connect up another hydrogen cell, and I could have them in a series, and I could have that electricity that they produce in a series, or just direct, you know, or in line, as they say. So I thought, you know, it'd be interesting to show you this experiment. So we've not got the hydrogen apparatus now connected up. You can see those are the hydrogen, those are the wires that generate the electrolysis. It's not connected up. That's because we've got plenty of gas now, or more than adequate enough to run that for probably an hour maybe. And I'm not sure yet whether it hasn't produced much water yet, but that is the byproduct, or the exhaust will produce water. Now, something to think about here, which I found very interesting. Excuse me. What I found interesting is this is a lot like confirming maths. So to start with, we have 3 and 4. We know it adds up to 7. But we can reverse the equation. We can have 4 and 3, which is the same amounts of things, but we reverse the mathematical equation and we get the same answer. We start with water, we break it into its simplest form, we use it in the hydrogen cell, and guess what we get back out as a byproduct? Water. So it's very environmentally clean. We could put that water that's generated in the exhaust back into the water in the system, so that we're not wasting anything at all in this system. That's why hydrogen cells and hydrogen energy, I feel, will be a big thing in the future. The big problem that the industry faces is, first of all, the cost of producing hydrogen. Secondly, the storage of hydrogen, not just at the stations where they're going to distribute it to the cars or generators or homes or whatever, but then it's also the storage in the vehicle as well, or the storage at home for that hydrogen gas. Those are some of the things that the industry is looking at. But like I said, you know, I don't think along the same normal lines as many people with regards to these things. I think a little bit out, what's the way of describing it? A little bit out of the box. And that's why I come up with the idea of using ion wind on the positive side, or on the hydrogen side of this hydrogen cell generator. Of course, if we're using ion wind, then it's no longer a hydrogen cell. It's an ion wind cell that generates electricity. So, like I said, over the coming weeks, we will be using ion wind pumped over the hydrogen side to see if it's a success or not. So preliminary experiments show that ion wind can be converted back. We can convert electricity into ion wind, then ion wind back into electricity. What we want to know is if when it runs through one of these cells, will it do what it's doing right now, but with not using hydrogen gas. So we don't just, like you guys think here, track and monitor the magnetic North Pole for you. We're also looking at alternative sources of energy as well, because I think you'll agree there needs to be something else, a newer technology out there where we can all have readily cheap electricity, especially in this day and age with the cost of living crisis and the recessions that we're seeing all around the world. And this ion wind, if it does work, is something very easily made and doesn't require a lot of knowledge in stuff, and can be made very cheaply. Even the equipment can be made cheaply. These, if you want to play with them yourself, are very cheap to buy. You can buy one of these on eBay for around £30 or less. And what I was thinking of doing is putting them in series so that we get more voltage. So the next one might bring us up to 1.5 volts, and then if we double that, we get 3 volts. And then you can just see, if you keep doubling them up, you're going to get more electricity. And obviously the more power electricity you have and the more milliamps you're generating, the more you can do with it. So over the next few weeks, I'll let you know what the results are, and maybe I'll be demonstrating the ion wind working in a positive fashion, generating electricity just as well as the hydrogen is there right now for you guys. Now, there is something I want to say. There is going to be some changes made to what we do here on YouTube, and that is because since October last year we lost a lot of our funding. I'm not sure, I think it was genuinely to do with the purse strings being pinched a little due to the cost of living crisis in a lot of the countries. I did find it very strange. I mean, you could be paranoid about it. You could say, oh, the government are doing this. They're pulling strings behind the back doors of, your funding. I don't think that's the case. I just think it's genuinely people are short on a few pound, and some people don't like, as they've told me, using PayPal. So we are going to do the positioning of the magnetic North Pole directly on Patreon. And we're also going to do the Earth Alpha at a glance, where we get the CO2 detector out and the atmospheric oxygen detector and put that on there. And we're going to keep YouTube for these videos and talking about, scientific related topics and experiments like this for you to benefit from, as well as some other things. But if you are interested in knowing the positioning of the magnetic North Pole, you can become one of our patrons for $5. That's not going to break anybody's purse string. $5 a month, guys. So, get ready, because on the 17th we're going to be doing a magnetic pole reversal positioning, and also we're going to be doing one at the end of the month. So 2 of those a month, and in between, for patrons only, we're going to be doing the Earth Alpha at a glance. And obviously we won't be leaving you entirely on your own here on YouTube, because we will be showing you things like this which are very interesting. I know you guys like these sort of practical experiments we do and relaying them back to you. So I was surprised, I'm really surprised that only on the small amount of hydrogen gas that we've actually allowed to flow over that it hasn't stopped working yet, and the voltage is still quite, at what it was. I know that when it drops down a little bit less than that, it will stop the motor turning and then require just a little pinch of the valve to allow that little bit more gas to go over the hydrogen side. But this was to show you how a hydrogen cell works, because the next phase is to hopefully show you that hydrogen cell working on ion wind only, which I'm pretty sure no one has ever achieved. But just what we've got here is enough to drive a motor, a tiny gearbox, and obviously, for the duration of this video anyhow, it has still been turning, and we're not producing any more hydrogen gas, so it's quite efficient. It's the wires going to the electrolysis, they've stopped, and we have got a volume of gas which is looking a bit gungy now because of the, I suppose that's to do with the galvanising being attacked by the salt in the solution and or the electrolyte. Okay, so hope you enjoyed it. Look forward to hearing your comments in the comments section, and I will say what I usually do: you take care of your loved ones. Look forward to seeing you over on Patreon, and take care. Bye for now.